Well, good evening, everyone. I hope that you are doing all right. Thanks so much for joining me tonight for a data classroom webinar, which we are calling Exploring an Unfamiliar Data Set with Data Classroom. If you don't have an account yet, you can always create a free account on the website at www.dataclassroom.com. I am the only one hosting tonight, and so if you have a question, feel free to unmute and yell out because I won't always be on the screen here, or type in chat and I'll try to check back in as much as I can. Could I get at least one confirmation that you are able to see my screen, please? A thumbs up or all
Yes, we
right.
can see it.
Hey, appreciate that. Thanks so much. Data Classroom is an online tool for data visualization and analysis. And we are really thankful that you took time tonight to join us in exploring a couple of unfamiliar data sets and just kind of get an inside look at one way that we do it at Data Classroom. My name's Nigel Standish. I'm a former high school math and science teacher in Tennessee and California. My PhD is in teaching and learning, particularly how students learn with their hands. And I am a former survival instructor for the Air Force. The school district I worked at was one of the very first to use Data Classroom in our science courses when it was in its beta stage. And when I left the public school system about 2 years ago, I joined on to help spread the good word about Data Classroom. So tonight, we're going to look at what are some guidelines or rules that we can use when looking at an unfamiliar data set, whether it's one we found ourselves and are interested in, or one that comes across our desk from a student, which is how most of the unfamiliar data sets that I see in this job come to me is from your students, actually. We'll be looking at some of those guidelines, and then we'll walk through a couple of examples. One of the first things that I like to do when I get a data set that I'm not familiar with is to just ask and try to find some of these questions in there, like who collected the data, why was it collected, how was it collected, if possible, although that question often is hard to answer in the line of work that I do, and to look at any documentation that I might find about that data set. Who collected the data is important to me because if a sixth grader collected the data, I'm going to be looking at it with a different eye than if some researchers at a university collected the data. Why it was collected is important to me because it kind of, just gives me any insight into the question that the researchers or the student was asking and whether there might be any biases for it. If we take a look at really quickly at this data set that we'll get into more depth later on, we'll see that this data set came from citizen science. And citizen science is a place where a lot of people can collect data and enter it, where it gets collated and then can be downloaded for use by anyone. And that's important when looking at data sets to help set our expectations and kind of give us a clue as to, where some pitfalls might be as we're looking at the data. Next up is I like to look at how many variables and what types of variables they are. The types of variables tell me what kind of visualizations I'm going to be able to create with that data, what kind of statistical analysis I'm going to be able to run, and what types of questions that I might be able to answer. And with those variable types, I'm going to be looking at the observations. Go back to this data set here, and we're going to notice that each column is a different variable, and each row is an observation. And a general rule of thumb is that for every variable, you want at least 20 observations. And so when I am looking at how many variables and types and how many observations, particularly if it's a student project, I'm kind of looking, trying to answer the question of, is there enough data to do a fair analysis of the question with what's available? The third point is, what is the unit of observation? Now, unit of observation might be an unfamiliar term, and that's because it was to me. But basically, it's what does each row represent? So we'll go back here and look at this data set, and we'll notice that each row does not represent a tardigrade because there's a lot of rows with zeros, right? Each row doesn't represent a high because there's also low. And by kind of parsing this data set, we realize the unit of observation is this variable called sample ID. So samples were collected every time, every observation, there was a sample collected, and then this information across the row was determined from that sample. Now, why this is important is because the unit of observation determines the questions we ask. So all of my questions that I ask in this data set have to be about the samples. How many, are there any difference in samples collected in high traffic or low traffic with the number of tardigrades? I can't ask questions about tardigrades, for example, in this data set without changing the unit of observation and reformatting this data set, which we can get into. So the unit of observation, or what does each row represent, determines the questions that can be asked of that data.
Sure.
Lastly, what format is it in? If we look at the data set we have here, we can see that it's in tidy format, which is good for analysis. Every column is a variable, and every row is an observation. And I'm just going to pause there for a second and come back to Zoom and take a look at the chat. Don't see any questions there. If I move too quickly or talk too fast, please just don't hesitate to interrupt and let me know what you're thinking or if you have any questions there. All right. So once we kind of have taken a look at the structure of the data, then we can start exploring it. And I just want to pop over to Data Classroom here. This is our dashboard. And at the top of your dashboard, you're going to be able to go into the resource library. And I'm just going to pick this springing forward data set here because where I am, we're just getting over an 8-inch snow, and I'm hoping for spring. And I'm just going to take you over to the assignments tab at the top and just point out that almost all of the data sets in the resource library will answer those first two questions for you. There'll be a background about who, what, why, and how collected the data. And then you'll get some information on the variables. And then some scientific questions and scientific data that will help you explore it there. For this data set, though, we're going to grab this data. And I'm just going to grab it by highlighting it. I'm using Google Sheets here, but you can grab it from any processing that you like. Do that. I'm going to copy it, and then I'm going to come back to Data Classroom, and I'm just going to import the data here. Now I can import it directly from Google Drive using this Fetch button. That actually creates a web link between the Google Sheet and Data Classroom, so that if you update the Google Sheet, it'll update your data in Data Classroom. This is handy for a long-term research project where you might want to start analyzing your data before you're fully finished collecting it. You can upload from your computer using an Excel or a CSV, or you can just copy and paste, which is what I'm going to do tonight. I am sure I want to continue, and we're just going to do tardigrades for life. All right. So once I upload or copy and paste this data, I'm going to have a little check mark saying, hey, you got your data in, but now I've got a little caution sign that I haven't fully prepared it. When I click on that, it tells me, hey, no description's been entered. This is a good idea for my future self or for any future people who look at my data. And then the types haven't been set. If I'm not sure what type each of my variables are, I can learn more about types. I can learn about the main different types. Most data is going to be either numeric or categorical, but we're going to see a couple different variations tonight. And then we can learn about tricky situations. So I will say, I'll fix this, and I'll enter a short description. Tardigrades from citizen science. Done. And then I will set some types. So this is going to be our info. This is categorical. This is another info, another categorical, and then we have some numerics right here. And now you see that once I've set my types and my description, I've got my checkboxes in data import and data prepare, and I'm able to move on to graphing. So I'll click on the graph tab here, and we'll go back to our slide because we're ready to see some of the ways that we explore the data. You kind of want to take it easy here. You want to explore one variable at a time, visualize distribution, any outliers, look at where there's groupings, and any differences that you might see. In this data set, all right, we'll just start with looking at the samples that were collected in the different trafficked areas. All right, so you notice I pull up my high and low traffic areas, and I can see that the number of samples collected in high traffic areas was 519. Oops. Can you see my screen now? All right. The number
Yes.
of, thank you. The number of samples collected in high traffic areas was 519, and the number of samples collected in low traffic areas was 312. And I'm kind of in my brain or on a notepad just taking note that the number of samples collected in each area are quite different. Over 200 samples different between high and low. And now I'm going to look at the number of tardigrades that I have. And the way I'm going to do that is I'm just going to change this to categorical quickly. I'm going to show it, and I'm going to put that on Z. All right. So now I'm looking at a rectangular base graph, um, and I'm looking at the number of tardigrades by traffic areas. And when I hover over the high category, I can see that in 498 samples, there were 0 tardigrades. And in the low traffic area, 303 samples had 0 tardigrades. So I'm kind of in my mind right now, just taking note that even though there's 200 plus sample difference between high and low, most of both of these categories had no tardigrades in them. Now, we can barely see some of these graphs in here. So I'm going to just pop up and try to get a better idea of what's going on by stacking them. And I'll just click stacked here. And so it's kind of reinforcing what I thought. There's mostly no tardigrades in each sample. There's a little bit there. Because these categories have different samples collected, the number of samples is different. I'm going to try stacking this as a proportion. All right. And this brings them up, everything's out of 100 now. And I can just do just a quick comparison here. So 96% of high had 0 and 97% of low had 0. 3% had 1 tardigrade, 2.5% had 1, 0.7% had 2, 0.3% had 2. And so I'm just kind of visually inspecting the data here. I'm helping myself out by stacking them and stacking as proportion, because I think that'll give me kind of a better idea of what's going on. And overall, I'm just kind of in my brain, making note that there's a lot of samples that don't have any tardigrades in them, in both high and in low. Let's go back to our slide here, and we're kind of just reaffirming that we're exploring the data one variable at a time. We got a little carried away there, maybe just looking at a couple variables, but we're visualizing the distribution. We're making notes of that in our mind or on a notepad, looking for outliers, which in this data set we don't have. And we're observing differences that we see between the variables. So let's just continue exploring. Well, let's go down here. Exploring maybe the relationships a bit more with 2 variables at a time, looking for differences and correlations. Let's go back to our data set. There we go. And let me just, while I'm taking a break here, just double check. Nothing in chat. All right. So some different visualizations that I might do with this data set is I might restrict the range just a bit. So let me unstack these and close this up, and then change the tardigrades back to numeric, and throw that there. Number of tardigrades on Z. Let me make that, there we go, Let's see. There we go. So you can see that there's so many samples with 0 that it really, minimizes those samples that had anything. So I can go in here and I can confine my y-axis to say, let's say 0, and we'll do 20. I think help click. Now, this gives us a clearer picture of the samples that had that had tardigrades in them, but it also is a misleading representation, isn't it? Because now the tops of our zeros are cut off, and you can see when we have auto how much taller those zeros appear, which is a more accurate visualization. But this one I did just to see, what it would look like if I scrunched the y-axis and just got a look at the samples that did contain tardigrades. All right, let me take that back onto auto there. Close this out and take that off of our Z. So looking at variables together, looking for differences and correlations. And then finally, as we're exploring data sets, we're asking questions. We can test hypothesis. We can create visuals for communication. And if necessary, although it's not always mandatory, running statistical tests. And I forgot to switch this back, so I'll give you a second to look at that one. And then we will go back to our tardigrades. All right, so I'm going to just unshow these. I'm going to make this one back to a numeric. And then we will switch to a dot plot. And we'll look at the traffic, the categorical variable of traffic on X, and the number of tardigrades on Y here. I have. Go ahead.
Sorry.
No worries. No worries. The number of tardigrades on Y. We've got a little, little dot here. I can set my jitter. There's only 2 categorical values, so the jitter has no meaning to the data, but it just makes it easier to see. And the question that this visualization is asking is there a difference in the number of tardigrades between high and low traffic areas? And if I click on our graph-driven hypothesis test, it's going to take a look at that graph and suggest that I run a t-test because I have 2 categorical values on X and a numeric on Y. A recently released option that you might not know about is the show advanced options in the top right corner, where you can see more statistical tests that might be appropriate for your data in here. And also with some non-parametric test options. But I'm going to click calculate here. This pop-up will tell us why we're using a t-test, when we should use it, and how it works. And when we click calculate, we will get our statistical test here. The degrees of freedom, a statistical score, and our p-value. Our p-value at 0.22 means that there's little to no indication that the groups might be different. If I'm new to p-values or statistical tests in general, I can click explain, and I'll get this pop-up where I can drag my p-value closer to 1, and I can drag it closer to 0, and I can see what that means as far as whether my data is random or whether it's real here. If I let go of the p-value, it snaps back to what my statistical test is that I'm running. If at any point I want to copy my statistical test, I can click the camera icon here and copy it onto whatever word processing or presentation software I'm using. The same goes for any of the graphs. They can just be copied and pasted there. All right, I am going to pop back to Zoom and just pause for a minute and take any questions that you might have.
What does it mean when it says the z-axis?
Yeah, thank you so much for asking that question, Krista. It is not a spatial reference. It's simply a third variable that you can put on the graph.
Okay. Thank you so much.
Yeah, no worries. It's funny that I had a AP research teacher who was a former geometry teacher asked me that question just a few days ago. So I appreciate it. All right, if there aren't any other questions, I am going to pop over to another data set right here. And I am going to tell you that I am truly unfamiliar with this data set. I have spent about 5 minutes looking it over. So you and I are going to explore this data set together. Now, I'm going to go back to our guidelines here. We'll go up to the top. And I will tell you that I don't know who collected this data. It was given to me this afternoon by my boss. It was collected to look at the factors affecting the price of cars. How it was collected, what was the design, I don't know, and I don't have any documentation. Let's look at the variables and types here. All right. So you can see that there are a lot of variables in this data set. Car names, car body, drive wheel, engine location, fuel type, aspiration. I'm not a car guy, so that one confuses me. Door number, I know that one. Cylinder number, engine type, fuel system. So there's a lot. And way over here on the right, there is the price metric. So let's take a look at, we can see most of these are numeric on the right, but there are a spattering of categorical ones here on the left. And so we're kind of just looking at the data. The unit of observation, I would say, would be the price. We're going to look at the price, and all our questions are going to be about the price and how it relates to other variables. And the next steps are to explore the data. So I'm going to pull up price here, set the jitter just a, here we go. So we can see that the price appears to center around 10,000, but it goes all the way up to 45,000 there. But I can click on descriptive stats and I can get a median-based box and whisker, pull up the values, and then let's take a look. So the minimum value is 5120. The max value is 45,400, and the median is just above 10,000 there. And that kind of just tells me that a lot of the prices of cars in this data set we're under 20,000 there. If I want to, though, let's see what happens if I pull this up into a rectangle-based graph. Once again, we'll see that a great deal fall between 5,000 and 10,000, and then it has a long tail off to the side there. With so many variables here, we do have another option for kind of exploring this in Data Classroom. And I'm going to pull that up for you by clicking on the hamburger menu and the advanced and going to correlation matrix. I'm going to select all here. I'm going to look at, we'll color negative values differently, and we'll close this out and put this away so you can see this. All right, so here's a correlation matrix with prices here along the bottom, and then there's different correlations to price all along this row. So we can look that these are all positively related. So the wider a car, the more expensive it is. The higher the curb weight, the bigger the engine size. But I'm interested in these red ones, these ones that are negatively related. So it says highway miles per gallon is negatively related to price, which means that the better the fuel efficiency, the cheaper the car. All right, let's test that out. So we've got price, and now let's find highway. There it is. All right, so the better the mileage, the cheaper the car. And I'm guessing that's because maybe some of these gas gugglers were muscle cars or luxury muscle cars, fancy cars that use a lot of gas per gallon. I think that city miles per gallon was also negatively correlated. And so we're starting to, just kind of look at some of these data. It looks like peak RPM has a slight negative correlation, but not a strong one. What was that one that I didn't know? It was aspiration. So, a standard or a turbo engine and price. So standard is slightly cheaper, it looks like, than turbo. If we want to see that mathematically, let's run this test and see what we get. It says, please contact support, but I am support. Why did that happen? All right, well, I'm going to put that in my notes and ask that question in the morning. But as we, go through these unfamiliar data sets, if we're kind of just going through them a little bit systematically and taking notes, trying to understand the context, understand the structure, explore the data slowly at first, one variable at a time, to familiarize ourselves with distribution and differences and any outliers. Then when we start exploring relationships between those variables, we can begin to see the correlations, the differences. And if we are doing that kind of systematically, then we're ready to ask or answer questions that data is capable of answering, testing hypotheses that we uncover, creating visuals that we can communicate with others, and if necessary, running some statistical tests.